Look at your smartphone. This miniature supercomputer guides you, connects you, informs you. Now, picture it, buried for 5 millennia, a relic for future archaeologists. What would they make of it? Would they dismiss its existence as impossible for its era? We've been taught history as a straight line, crude tools to complex machines, cave to wheel to steam to AI. That's a textbook myth, a comforting narrative. The reality is far more chaotic, far more fascinating. Human progress doesn't follow a linear path. It's a spiral, flashes of impossible brilliance, then silence, then a painful rediscovery. Tonight, we're unearthing discoveries that appeared thousands of years too early. Precision engineering, climate control, automated logistics, not in Silicon Valley, but in societies we dismiss as primitive. We'll reveal these lost wonders weren't magic. They were products of physics. The true mystery isn't, could they build it, but why such groundbreaking technology vanished, leaving only whispers. Its disappearance echoes in our own hyper-connected world, a chilling warning from the past. Consider this, a deep-water harbor, not in the modern era, but millennia ago, where ships sailed in on a perfectly consistent water level, day or night, regardless of the ocean's relentless tides, an ancient automated dock guiding vessels with synchronized light signals. This wasn't a myth. Archaeological scans have consistently revealed subterranean structures of impossible precision, whispers of Atlantean engineers, or perhaps even otherworldly assistants, feel almost rational when you witness the sheer scale and accuracy of these finds. The audacity of engineering such a system, thousands of years before our textbooks say it was possible, challenges everything we think we know about ancient capabilities. But let's be clear, this was purely mechanical. Imagine a giant, submerged seesaw, perfectly balanced. As the tide rises, massive hollow chambers fill, creating buoyancy that pushes against counterweights, slowly closing a gate. As the tide falls, the water drains, and the counterweights pull the gates open. It's like the float valve in your toilet tank, but on an epic structural scale, synchronized to the lunar pull. The navigation lights, not electricity, but polished obsidian and bronze mirrors, funneling natural light or torch flame through conduits, flashing in sequence by simple clockwork-driven shutters. An ancient airport runway, lit by pure ingenuity. The real question, the lingering doubt, isn't how they built it, but why it disappeared. The answer lies in its complexity, the immense, specialized labor required for maintenance, the constant calibration, one catastrophic storm, one structural failure, and that entire marvel, that ancient automated dock, became a monument to ruin, too costly to rebuild, too intricate to maintain, without a vast, dedicated workforce. They didn't need miracles, they needed margins. And moving on to a different kind of impossible comfort, picture a bustling desert port city. It is not merely surviving the inferno, but thriving in luxury. Thousands of years before anyone dreamed of air conditioning, our scans reveal undeniable proof of localized climate control within these ancient urban centers. Was it some lost alchemy? A gift from advanced beings, perhaps? Such a wild menu of theories always makes for a dramatic story, yet we deal strictly in evidence. Forget the myths. Look at your modern data center and the way it keeps processors from melting. This ancient marvel operated on the same fundamental principle. Imagine vast, insulated conduits drawing frigid water from deep aquifers or even geothermal vents. This water served more than just drinking needs. It snaked through a hidden network of ceramic pipes woven into the very walls and floors of entire districts. It functioned as a gigantic, passive, radiant cooling system, a smart home concept, art applied not to one villa, but to a whole city quarter. The engineering was precise, though the logistics remained immense. maintaining their pristine water source, preventing catastrophic leaks across miles of hidden plumbing, and the sheer initial energy investment required to carve and install it all. This wasn't some mystical secret. It was pure applied engineering, executed at a scale we're only now beginning to appreciate. The real mystery isn't, could they, but how did they sustain such a complex, resource-intensive marvel for so long? The Earth itself holds secrets, and we possess the keys. Our AI-enhanced LiDAR does more than peel back jungle canopy. It slices through millennia of sediment, laying bare an impossibly intricate subsurface grid. Beneath the missing wonder site, we found a labyrinth of conduits, chambers, and structural foundations. While the initial knee-jerk reaction might suggest alien landing patterns or vast hidden cities, those fun narratives fade when our data points to something far more pragmatic, yet equally mind-bending. Ground-penetrating radar and thermal imaging confirm it. A vast network exists. Imagine your city's entire utility infrastructure: water, waste, climate control, all pre-planned and integrated, but thousands of years too early. Aqueducts, pressure chambers, and heat exchangers were all precisely aligned to cardinal directions and local topography. Consider the sophisticated plumbing in a modern skyscraper, where every pipe has a purpose and every gradient ensures flow. This was that, but stretched across miles and buried deep. The sheer volume of excavated earth and the tonnage of stone moved is like digging out 40 Olympic swimming pools by hand, then lining them with precision. The exactitude of the pipe laying and the gradient for flow are all there, screaming, engineered. This wasn't magic, it was physics. Yet the sheer scale of its construction, lacking modern machinery or a single bulldozer, remains a profound logistical puzzle. Who commissioned this colossal undertaking? How was it organized, maintained, and why did it vanish from history? What happens when you don't just scan the Earth, but start analyzing the very stuff they built with? Fragments recovered from the ash layers, when subjected to X-ray fluorescence, reveal alloys and composites with properties that utterly defy our textbook understanding of ancient metallurgy and ceramics. Materials designed for extreme heat, for corrosion resistance, for structural integrity that should not exist from that era. Was this lost alchemy, or perhaps metals from the heavens? The romantic theories are seductive. They always are. Discard the supernatural. This was pure applied material science. We're finding irrefutable evidence of specialized ceramic linings, layered composites of different clays, and copper alloys infused with precise trace elements like tin, arsenic, and nickel. Such findings aren't guesswork. They indicate controlled smelting for specific mechanical properties. Consider modern aerospace materials, engineered to withstand the brutal forces of re-entry or the corrosive environments of deep-sea exploration. These ancient artisans possessed a similar, profound understanding. They knew exactly how to make things tough, light, and durable for specific functions within their grand system. Still, the residual itch remains. How did they achieve such unwavering quality control and precise material composition without laboratory conditions, without the sophisticated analytical tools we rely on today? It suggests a highly specialized, perhaps even secretive, industrial process, operating at a level of consistency that continues to baffle us. Those impossibly strong ceramics and precisely alloyed metals, they weren't for trinkets. They were the very bones of a system that ran an entire city. Look at the port city's infamous shipping lists. For centuries, historians dismissed them as mere inventories. We now see they were the operational logs of an automated cargo handling system. Forget robot porters or mythical cranes lifting impossible loads. Visualize goods arriving at the docks, embedded with simple physical markers. These weren't just labels, they were codes. Water diverted from the harbor itself created currents and pressure differentials, activating a network of conveyor belts and counterbalanced lifts. Imagine a vast, intricate vending machine, but for entire ships' worth of cargo. The system read the codes, sorting and shunting crates, amphorae and bales to their precise storage or processing zones. The city itself, an ancient computer of hydromechanical logic, running on nothing but physics and gravity. This wasn't sorcery, it was pure engineering. The ash, that terrible ash, preserved not just the objects, but the imprints of the wooden and metal components that once moved this silent, efficient ballet of commerce. But here's the profound dependency. A system this complex, this integrated, created a single point of failure. The city thrived on its efficiency, but it also became utterly beholden to its smooth operation. A disruption, a blockage, a single catastrophic event, and the entire economic engine seized. The mystery isn't, could they build it? It's, what happens when such brilliance, when such centralized power becomes fragile? We've seen the impossible hardware. We've traced the intricate logistics. So, what happened to this marvel? This ancient smart city? This automated port that outpaced anything for millennia? Was it divine fury? A sudden alien exodus? Hardly. The evidence points to something far more mundane, yet brutally tragic. Running such a vast automated network with its precise ceramics and hydromechanical logic demanded immense sustained capital. It required a vast specialized workforce and a unified political structure. Think of a house of cards, incredibly complex, yet incredibly fragile. A shift in global trade routes, a devastating war, or even a prolonged drought could cripple its funding, starve its specialized labor, and fracture its political will. They didn't need miracles. They needed margins. The volcanic ash, which froze our discoveries in time, was likely the devastating final blow to a civilization already teetering on the brink. The system didn't fail technologically. It failed economically, politically. The ash then buried it, leaving us only these tantalizing clues. The mystery isn't, could they? It's, why didn't it spread? The answer is rarely a lack of ingenuity, but almost always a lack of sustained economic and political will. Look at your smartphone again. This tiny slab of silicon and glass connects you to the entire world. Consider the vast, intricate web of global shipping that brings its components to you, or the sprawling data centers humming invisibly in the desert, holding all human knowledge. Imagine future archaeologists, 5,000 years from now, sifting through the ruins of our cities, unearthing our buried marvels. Will they gaze upon these relics and see magic? Or will they grasp the underlying physics, the logistics, the sheer engineering? Might they comprehend the intricate economic and political dynamics that nurtured these complex systems, or ultimately led to their abandonment and decay? Such questions aren't merely about distant history or forgotten empires. They stand as an existential mirror, reflecting our own vulnerability, the inherent impermanence of even our most sophisticated designs, the profound fragility of the societal frameworks that enable such advancements. These are truths etched into ancient ledgers, in layers of volcanic ash, and in every forgotten blueprint. Civilization's march isn't a straight line. It's a relentless spiral. Time and again, groundbreaking technology simply vanishes, not because it was some impossible enchantment, but because the economic viability evaporated, the social contract fractured, the political will dissolved. We are left with only enigmatic whispers to painstakingly decode. If they forgot, if they lost it all, what makes us so certain that we won't?